Welcome to Homework Lib.
Hi, so in this question we wish to find the enthalpy of reaction for the following 3 iron 2 O3 as a solid plus CO as gas producing 2 of iron 3 O4 as solid plus CO2 of gas. And the information that we're given is that we have access to the following reactions: 4 iron S plus 3 O2 producing 2 of iron 2O3. So this is the standard enthalpy of formation corresponding to this compound. Well, actually multiplied by 2. We know that delta H naught over here is minus 1652 kilojoules. Next up, we're going to have carbon, solid, graphite, plus 1/2 of O2, producing CO gas with an enthalpy of minus 110.5 kilojoules. Following that, 3 of iron solid plus 2 of O2, producing iron 3O4 as a solid. For this, the reaction has an enthalpy of minus 1117 kilojoules. And finally, we have like the opposite of the enthalpy of formation for carbon dioxide. So we have carbon graphite plus O2 as a gas. And in this case, delta H naught, it is going to be equal to 395.5. Okay, so now the nice thing that we can use for Hess law is that we need to find a combination of these reactions that provide us with the correct stoichiometry and the correct reactants and products of my original reaction. So, first thing first, I have iron 2O3 towards the left. So what I need to do is to switch sides on this reaction, and that is going to make the delta H to change as well. So 2 of iron 2O3 is going to produce 4 of iron solid plus 3 of O2, and the delta H for this is going to be 1652. Remember, when we switch up the values, we need to change the sign of the enthalpy. Next up, I'm going to do the same with the one of CO gas, because I have CO as a reactant. So CO gas going into carbon solid plus 1/2 of O2, and the delta H of this reaction would be 110.5 kilojoules. And CO2 is going to be a product, so carbon solid plus O2 is going to generate CO2 as a gas, and the delta H of this reaction would be minus 395.5 kilojoules. A little bit of a hint, this reaction corresponds to the standard enthalpy of formation of carbon dioxide. So this would be the answer for part B, direct. And the final one that I'm going to use without switching up is this equation over here. So let's put it in black because I didn't switch it. 3 of iron solid plus 2 of oxygen. It's going to produce iron 3O4 as a solid. And the delta H for this reaction will be minus 1117 kilojoules. Of course, all of these values are per mole of reaction. Okay. So now, finally, what I need to do is to make the coefficients match up. So, for example, I'm going to employ purple to write down what is the correct amount that I should get on each of these guys. So in the case for iron 2O3, what I want is a 3 in my reaction, right? But right now I have a 2. How do I get rid of that? I multiply the whole equation by 3 halves. Of CO, I have only 1, so I can just leave it like that. Of CO2, the product, I also only have 1, so I'm good to go. Times 1. And for the final one, I'm going to multiply this by 2. After I have done that, to be like extra thorough, if you want, you could like go ahead from here and just do the calculations, but just for sake of being as clear as possible, the new reactions are going to be 3 of iron 2O3 producing 6 iron plus 9 halves of O2, corresponding with a delta H naught of 2,478 kilojoules. Remember, you need to multiply it by the same number. The one for CO, it stays the same. CO gas producing carbon solid plus 1/2 of O2. The delta H naught stays the same, 110.5 kilojoules. The one for CO2 also stays the same. Carbon solid plus O2 produces CO2 gas. Delta H naught equal to minus 395.5 kilojoules. And for the final one, 6 of iron plus 4 of O2 is going to produce 2 of iron 3O4 with a delta H naught equal to minus 2,234 kilojoules. And now we can add up all of these reactions. We're going to sum them and do the sum of the delta H's. Let's see what quantities are going to cancel out before we continue. Here we have carbon and carbon. They are going to cancel completely. On this side, I have 10 halves of O2 corresponding to 5 O2. They're going to cancel out with 1 and 4, 5 O2 on the left hand side. So they cancel perfectly. 6 of iron cancel out with 6 of iron. Are going to get our final reaction, that is the one that we desired from the very beginning. So 3 iron 2O3 as a solid plus CO as a gas is going to produce 2 of iron 3O4 as a solid plus CO2 as a gas. And the enthalpy for this reaction is simply going to be the sum of all of the numbers I have over here, which is minus 41 kilojoules for this reaction. And that would be all. For part B, as I mentioned, the answer is minus 395.5 kilojoules, but we saw that directly by looking at this reaction. And that would be all. Thank you very much.